Hi everyone, I'm going to present our work, fuzzy uncertain self-supervised learning. Self-supervised learning has offered tremendous success in feature learning, especially visual feature learning from unlabeled data using a supervisory signal derived from the data. We recognize the fundamental limits of SSL coming from the single supervisory signal, and uh, we address this limitation by leveraging the power of uncertainty representation to devise a robust and general standard hierarchical learning training protocol for any SSL. So here feature learning is decomposed into two stages: training procedure with double supervision, each stage with its own supervision sample level. The first one is sample level supervision, and the second one is cluster level supervision. And extensive experiments support the confirms the effectiveness of this training protocol for different SSL approaches. Here we have the motivation. I would present motivation in two different sets of motivation. The first one is double supervision. Almost all of the SSL baselines use single sample level supervisory signal to enforce invariance to data augmentation and learn the features from unlabeled data. However, we propose double supervision, which is based on sample level and also cluster level supervision. Also, robustness, uncertainty, and in general robustness has gone have long been underexplored, and our framework provide an opportunity to consider more robust SSL frameworks or training procedure for SSL frameworks. Here you can see the general pipeline of FUSSL. As you can see here, we have we have an ensemble of, for a given approach such as Barlow twin, we have an ensemble of models of Barlow twin or any given approach, and then after augmenting data and assigning the augmented view to each of these blocks, we train them in a standard procedure, and then this is the first phase training, and then we feed them with the unlabeled with the original samples, and using the output of each of these blocks, we provide a FUSSL pseudo label for each sample to use them in the second phase of training. So first phase of training helps is done in for 800 epochs, and the second phase is 400 epochs. The first phase allows to capture low to medium granularity features, and the second phase is to capture the more task relevant features or higher level features. As you can see here, this is the results for table 1 present the result for linear classification accuracy for ImageNet using ResNet 50, and the table 2 to present the transfer learning classification accuracy for Cypher 10 and Cypher 100. Also, this figure presents the accuracy improvement for different sizes of ensemble. As you can see here, also table 3 and table 4 provide some investigative scenarios, including class and cluster feature learning and other scenarios discussed in the ablation study. Conclusion: this work presents a general training protocol for any SSL baselines, which provides a double supervisory signal for learning a larger range of features. Thank you so much.